This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on related rates. We're starting with the equation x squared y cubed plus 2x minus 3y equals 5. And we want to find some information. We're told dx dt is 4 when x is 2 and y is 1. At that instance, what is dy dt? So we're going to take the derivative with respect to t to enable us to do that. So the derivative with respect to t of the left-hand side equals the derivative with respect to t of the right-hand side. The derivative of a constant is 0, so we know that. The derivative of the sum is the sum of the derivatives. That will be the derivative with respect to t of x squared y cubed plus the derivative with respect to t of 2x minus the derivative with respect to t of 3y. And again, the right-hand side will be 0. So where do we go next? We recognize that we can pull the constants out. So 2 comes in front of this ddt operator. 3 comes in front of that ddt operator. The derivative with respect to t of 5 is 0, as was mentioned. Now, the derivative with respect to t of x will be dx dt. The derivative with respect to t of y will be dy dt. And then all we'll have to do is the derivative with respect to t of that product. And to do the derivative with respect to t of that product, we're going to need to use the product rule. So uv quantity prime is u prime v plus uv prime. So keep that in mind as we now look to find the derivative with respect to t of x squared y cubed. So I'm saying u is x squared and v is y cubed. Now u prime will be the derivative with respect to t of x squared. Keep that in mind. V prime will be the derivative with respect to t of y cubed. So the derivative with respect to t of x squared, something squared, 2 times the something times the derivative of the something, 2x dx dt. Same thing over here, the derivative of something cubed, 3 something squared times the derivative of the something, 3y squared dy dt. So what does that give us? 2x dx dt, v prime 3y squared dy dt. So recall our product rule, u prime v, so 2x dx dt times y cubed plus uv prime plus x squared times 3y squared dy dt. That will be the derivative with respect to t of this product, x squared y cubed. Again, u prime v, 2x dx dt times y cubed we have here, plus uv prime plus x squared times 3y squared dy dt. So we're going to substitute this in for this piece and continue with our algebra. That is now substituted in, and at this point we recognize x is 2, y is 1, dx dt is 4. So this should be 2 times 2, x is 2, dx dt is 4, y cubed, 1 cubed, plus x squared, 2 squared, times 3 times y squared, 3 times 1 squared, dy dt is what we're looking for, plus 2 times dx dt, 2 times 4 minus 3 dy dt, that's what we're looking for. So again, you can see x is 2, dx dt is 4, y is 1 cubed, x squared is 2 squared, 3 times 1 squared, dy dt plus 2 times 4, dx dt is 4, minus 3 times dy dt. So let's do the arithmetic here. 2 times 2 is 4, times 4 is 16, 1 cubed is still 1, so that first piece is going to be 16. This is 4 times 3 times 1, that's going to be 12 dy dt. Over on this side, 2 times 4 is 8, minus 3 dy dt is 0. 16 and 8 is 24. 12 minus 3 is 9, so 12 dy dt minus 3 dy dt would be 9 dy dt. So we get 24 plus 9 dy dt is 0. Adding negative 24 to both sides, 9 dy dt is negative 24, dividing by 9. Dy dt is negative 24 over 9. Reducing the fraction, divide by 3, divide by 3. And the result is negative 8/3. Our next example says a point is moving along the graph xy equals 36. When the point is at 4, 9, certainly 4 times 9 is 36. The x-coordinate is increasing at a rate of 2 centimeters per second. How fast is the y-coordinate changing at that time? So we're told we have this function xy is 36. We're told x is 4. We're told y is 9. X is changing, dx dt increasing, positive 2. We want to find dy dt. So this is all the information we're given. And to solve this, we're going to take the derivative with respect to t of both sides of that equation and then substitute in the various values to solve for dy dt. So here are those values copied again. The derivative with respect to t of xy is the derivative with respect to t of 36. The derivative of a constant is 0. The derivative of a product requires the product rule. U is x, v is y. U prime is the derivative with respect to t of x. V prime is the derivative with respect to t of y. But the derivative with respect to t of x is dx dt. The derivative with respect to t of y is dy dt. And then our result is u prime v dx dt times y plus uv prime plus x times dy dt equals d dt of 36, 0, the derivative of a constant is 0. Now we know dx dt is 2, we know y is 9, we know x is 4, and we want to solve for dy dt. So making that substitution, again dx dt is 2, again y is 9, x is 4, solve for dy dt. 2 times 9 is 18, 18 plus 4, dy dt is 0. Subtract 18 from both sides. So therefore 4 dy dt is negative 18, and divide by 4. Dy dt is negative 18 over 4, or negative 9 over 2. And our units on this problem are centimeters per second. And we continue. A rock is thrown in a still pond and it causes a circular ripple. If the radius of the ripple is increasing at a rate of 2 feet per second, how fast is the area changing when the radius is 10 feet? So it's a circle. We need to know the area of a circle is pi r squared. We have that. The radius is increasing at a rate of 2 feet per second, so dr dt is 2. Keep in mind the units, feet per second. How fast is the area changing? Find dA dt when the radius is 10 feet. So we'll start with a equals pi r squared and take the derivative with respect to t of both sides, and then do the substitution we need to find dA dt. There's the information we're given. The derivative with respect to t of a is the derivative with respect to t of pi r squared. The left-hand side, derivative with respect to t of a is dA dt. Right-hand side, pi is a constant. Pi can come out to the left of the derivative operator. So we get dA dt is pi times d dt of r squared. What's the derivative of something squared? 2 times the something, 2r, times the derivative of the something, times the derivative with respect to t of r. That will be 2r dr dt. At this point, we're going to plug in everything we need to solve for dA dt. Pi is a constant, r in this case is 10, and dr dt is 2. 10 centimeters, 2 centimeters per second. So if you look at our units here, centimeters times centimeters per second is square centimeters per second. In terms of our numbers, 2 times 2 is 4, times 10 is 40, 40 pi. 40 pi centimeters squared per second, 40 pi square centimeters per second is our dA dt. And one more example here. The production output per week is X. If production is increasing at a rate of 500 items per week, so we're going to think about how X is changing, dx dt is 500. And the current production level is 1,500 per week, so our current X is 1,500. Find the rate of change for cost, revenue, and profit. Let's start with cost. So we have C equals 72,000 plus 60X. Again, what's our information? Production is increasing at a rate of 500 items per week, so dx dt is 500. Current production level is 1,500, X is 1,500. We want to find the rate of change for cost, revenue, and profit. That would be dc dt, dr dt, and dp dt. So we'll start with cost. So our cost function is 72,000 plus 60x. There's the revenue function. There's the things we're looking for. So ddt of c, the derivative with respect to t of c, is ddt of 72,000 plus 60x. And I've gotten rid of this of x because I want to focus on c rather than the independent variable x. So ddt of c is dc dt, is the derivative with respect to t of 72,000 plus the derivative with respect to t of 60x. This piece, of course, is just 0. The derivative of a constant is 0. I can pull the 60 out in front. That would be 60 times ddt of x, or 60 dx dt. And then what do I know? We said that dx dt was 500, so I can go ahead and plug that in. So we get dc dt is 60 times 500, or $30,000 per week. So it's increasing. Our costs are increasing at this moment. We have revenue here. We want to find dr dt as well. So ddt of r is ddt of 200x minus x squared over 30. d dt of r is dr dt, is the derivative of 200, derivative with respect to t of 200x minus the derivative with respect to t of x squared over 30. Have an extra r here, I will fix that. And that's fixed. d dt of r is dr dt is the derivative of this piece minus the derivative of that piece. So pulling out the constants, we get 200 dx dt minus 1 over 30 d dt of x squared. d dt of x squared will be 2x dx dt. And then I guess we could simplify this a little bit. 2x over 30 is x over 15. Plugging in our values, 200 dx dt is 500 minus 130, 2 times x, 2 times 1500 times dx dt is what we get for our dr dt. And then multiplying all of that out, we get $50,000 per week. So that's how much the revenue is increasing, which is more, frankly, than the cost was increasing. So that'll tell us something about the profit. Now, I've actually gone through and done dp dt for the profit. Let me quickly show you that. Profit is revenue minus cost. There's the revenue function, there's the cost function. So 200x minus x squared over 30 minus quantity 72,000 plus 60x. That is our profit function. Again, profit is revenue minus cost. And I want to find dp dt, so I'll do it the same way. Distributing the negative, minus 72,000 minus 60x. And then 200x minus 60x is 140x, so we've simplified things a little bit. And I want to get dp dt, so the derivative with respect to t of p is the derivative with respect to t of all of this, which is the derivative with respect to t of the first piece minus the derivative with respect to t of the second piece minus the derivative with respect to t of the third piece. The derivative of a constant is just 0. I can also pull out the multiples. 140 comes out in front. 1 over 30 comes out in front, so I get minus 1 over 30 d dt of x squared. d dt of x is dx dt. d dt of x squared 2x dx dt, which is what you see here. Now I can plug things in and see what I get. So doing that, dx dt is 500, x is 1500, dx dt is 500. And you'll notice we get $20,000 a week, which was actually the difference of dr dt and dc dt. Can you see that? If profit is revenue minus cost, P prime should be R prime minus C prime. So indeed, that's a nice little way to check our work. And that will conclude this lesson.